Hi, my name is Leah Hairston, and this is my research presentation on improving ultraviolet nail lamps by evaluating the best replacement option for the UV light in nail lamps. So, to give a little bit of background, in 2011, it was found that men are 30% less likely to develop squamous cell carcinoma, or SCC, which is a type of skin cancer. And this is due to the direct correlation of the use of UV nail lamps by women. So, what do UV nail lamps do, and why are they used in the first place? UV nail lamps use UV light to trigger the photoinitiators in gel nail polish, causing them to break their bonds and initiate the curing process. To go more into that curing process, photoinitiators absorb the UV light and become a reactive species by breaking their original bonds and going into a polymerization reaction to create new bonds, thus solidifying the resin. However, UV light has been found to be harmful to skin due to the intense short wavelengths, which can cause a multitude of things, but mainly hyperpigmentation, premature skin aging, SCC, and other types of skin cancer. There have been preventative measures taken to not only prevent against UV light harm caused to the skin, but also caused to other parts of the body, such as sunglasses, gloves, and sunscreen. However, with these preventative measures, such as sunscreen and polystyrene lids, which are made from the same material as Tupperware, there was still decreased cell viability even when using UV LED nail lamps. The reason I emphasize UV LED nail lamps is because nail lamps weren't always made with LED lights. Nail lamps were originally made with fluorescent lights, which are much more harmful than LED lights. This is because fluorescent lights discharge harmful gases, whereas LED lights don't discharge harmful gases and also cure nail polish faster, lower heat generation, and also are more energy efficient. But the main reason these lights are able to cure nail polish is due to the short wavelengths of UV light itself. However, like I stated, UV light is harmful to the skin, which is why I decided to use red light because it has longer wavelengths, and why I also decided to use green light because it still has the shorter wavelengths, but has been found to be less harmful. So both types of light don't harm skin, but instead benefit skin by fixing redness, inflammation, and hyperpigmentation. We know these are less harmful because they are able to be used in a recreational and a home setting. This is because there are red light therapy mask and green light therapy mask that can be used without the need for a professional to be present. Next, we have the economic feasibility. So, my project is driven by the increasing consumer demand for safe cosmetic and beauty solutions, which is why I looked into nail lamps in the first place because, like I found, there have been no initiatives taken to develop a suitable replacement for the current nail curing technologies. Which led me to my research question of what color light is the best alternative to the UV nail lamp to alleviate long-term carcinogenic effects of UV nail lamps. Which leads me to my project goal, which aims to improve nail lamps by replacing the UV light in nail lamps to red and green LED light to make sure that nail lamps are less carcinogenic. Next, we have my methods. This is my method schematic, and I will be going more into depth. So first, we have the material selection. So I selected these materials because they were able to be used in both a professional and non-professional setting. And I selected these colors of nail polish because they are very common when making designs and have been used in one of the most common types of nail styles, which is known as French tips. Next, we go into disassembling the lamp, The lamp split up into these many different parts, but I mainly focus on the LED light plate that is found in the lamp. Next, we go into desoldering the lamp. So I desoldered the light plates and the wiring of the nail lamp to detach the light plates and measure them out. That way I could make a computer-aided design, also known as a CAD, and get the appropriate measurements of the light plates. So I could then cut them out using a laser cutter, which was in the engineering lab at my school. Once the light plates were cut out, I arranged them to align with the original light plates and the original measurements. Next, I installed the light plates using parallel circuit wiring, which means I attached each of the lights individually to the power source. Next, I tested the different traits of the nail lamp. So I tested the timer, the sensor, and the power cord/port, which worked after installing the new lights and the new light plates. So next, I looked at the performance of the nail lamps and how they affected current nail polish. So I looked for separation, opacity, and air bubbles, which are not desirable for a finished nail. Going into the performance again, so under the conditions, UV light still performed the best because that's what the nail polish was made for. The color was vibrant, there was no air bubbles, there was no opacity, and there was no separation. Going into the green light, there was opacity, there were no air bubbles, and there was a little bit of separation in the finished product. Going into red light exposure, there was a lot of separation. There was a lot of opacity, and there were no air bubbles. And when I did the controlled variable, when the nail polish was not exposed to light at all, the nail polish did not dry. So next, going into the cost analysis, I concluded that red light is going to be the cheapest to produce because mainly of the cost of the lights. So next, going into the time it takes for the different colors of light to be able to cure the nail polish. So for UV light, it takes 1 to 2 minutes per layer of nail polish. For green light, it takes about 10 to 12 minutes for the light to be able to cure the nail polish. And for red light, it took about 12 to 14 minutes or 12 to 16 minutes for the light to be able to cure the nail polish. So these findings led me to the conclusion that red LED nail lamps would be the most cost-effective to produce. Red and green LED lights took longer to cure than UV LED lights, and all panels and lights fit into the nail lamp after assembling the nail lamp. I also concluded that it takes about 10 to 16 minutes to cure the nail polish when using alternative light sources. Based off these conclusions, I concluded that green light is the best replacement option for the for the light in UV nail lamps. So to go into some of my limitations, my sample size was not very large. There are still many other colors of light that need to be tested, and there are also other colors of nail polish that need to be tested. Um, I'm not able to test on human subjects because it wasn't feasible at the time for me, and I'm also not a professional engineer, and this is the first time I've ever engineered something. And then for future research, I recommend that new nail polishes that are be formulated that are able to cure under green light. There are two types of resins that I found, which are green light marine grade epoxy resin, which is mainly used for underwater sources, but there is also another resin called opal dam green resin, which is used for dental fillings, which takes roughly 20 seconds to cure, which I concluded would be the best replacement of the UV resin in nail polish. Thank you, and these are my references.